In this video, we will look at coordinate geometry. So this topic you have learned in your secondary school, Form 4 and Form 5. So we will just take a quick look at this chapter. So let's start with the distance between 2 points. Let's say we have we have 2 points. Let's say we have 2 points, point A and point B. If you want to find the distance between point A and point B, so this is the formula that we're going to use. Distance of AB, square root of x2 minus x1 squared plus y2 minus y1 squared. Or you can use x1 minus x1 minus x2 squared plus y1 minus y2 squared. So normally we will label the point and then we are going to use this formula to find the distance. So let's look at one example. Let's say the first example. Find the distance between the point P and point Q. So in order to find the distance of PQ. So let's say I write down the formula. Distance of PQ. Where the formula is square root of x2 minus x1 squared plus y2 minus y1 squared. So you can start with label the point. So where here is x1, y1, x2, y2. So by plug in the formula, so our x2 will be 4. So in the bracket, 4 minus, again, so in the bracket, x2 is 4. So 4 minus x1. x1 is negative 2. So I put a bracket, negative 2 squared plus y2, which is negative 1. So negative 1 minus y1 is 7. So minus 7 squared. So from here, square root of 4 minus negative 2. So negative will become positive. So here will be 6 squared plus negative 1 minus 7. So here is negative 8 squared. So it's equals to 36 plus 64. So from here is 100. So square root of 100 will be equals to 10. So in here we are using the unit. So the distance is equals to 10 unit. Next, we look at the midpoint between 2 points. So if you want to find the midpoint M, so where the midpoint of A and B, which is M, so we can use x1 plus x2 over 2, y1 plus y2 over 2. Now we look at example 2, the second example. Example 2, find the midpoint of the straight line joining the point A and B. So now we want to find the midpoint. So from here, let's say I try to label the point. So here will be x1, y1, x2, y2. So the formula for the midpoint will be midpoint of AB is equals to x1 plus x2 over 2, y1 plus y2 over 2. So from here, where my x1 is 1, x2 is 7. So it means that 1 plus 7 over 2, x2 plus y2. X1 plus x2, so 1 plus 7 over 2, y1 plus y2 over 2. So y1 is 6, y2 is 4. So over 2. So from here, I should have 8 over 2, 10 over 2. So the coordinate will be 4 and 5. Next, we move on to the x-intercept and y-intercept, or we know as the axis. If the question mentioned about axis, means that we need to find the x-intercept and y-intercept. Based on this diagram or this graph, you can see that the y-intercept is in the y-axis, where x is 0, whereas the x-intercept is on the x-axis, where y is equal to 0. So you can look at this one. X-intercept is the intersection of the straight line at x-axis. The intersection of straight line at x-axis. At x-intercept or x-axis, y is equals to 0. Whereas y-intercept is the intersection of straight line at y-axis. So intersection of the straight line at y-axis. So at y-intercept or y-axis, our x is equals to 0. So axes refer to the x-axis and y-axis. Let's look at one example. Example 3. Given the straight line 5y minus 3x is equals to 15, cut the x-axis and y-axis at point A and B respectively. So means that respectively means that at x-axis will be the point A. Y-axis will be the point B. So find the coordinate of points A and B. So at point A. So here is the point A at x-axis. So you have to remember at x-axis, y is equals to 0. So I will substitute into this equation 5y minus 3x is equals to 15. So when y is equals to 0, 5 times 0 minus 3x is equals to 15. So 5 times 0 will be 0. Negative 3x is equals to 15. X will be 15 divided by negative 3. So will be equals to negative 5. So for x-intercept, so for point A, therefore, for our point A will be equals to, the x coordinate is negative 5. Of course, our y coordinate is 0. So this is the coordinate of A. Now we try to find the coordinate of B. So B is at y-axis. So you have to remember at y-axis, x is equals to 0. Again, we will substitute into this equation 5y minus 3x is equals to 15. So where my x is equals to 0, so here we will substitute 0. So 5y is equals to 15. Y is equals to 15 over 5. So y is equals to 3. Therefore, the coordinate of B will be 0 and 3. So this is the coordinate of B. Now we look at the gradient of a straight line. Let's say we have 2 points, x1, y1, x2, y2. In order to find the gradient of AB, or we can know as the slope of AB, or the symbol is M and the small letter of AB, so it's y2 minus y1. Please remember, the numerator is y. So y2 minus y1 over x2 minus x1. So the numerator will be y, the denominator will be x. So y2 minus y1 over x2 minus x1. So let's look at the example. In example 4, find the gradient of the straight line which passes through point P and Q. So we need to find the gradient of the straight line. So again, I start with label the point x1, y1, x2, y2. So the gradient of AB, so I can use not AB, but PQ. MPQ will be equals to y2 minus y1 over x2 minus x1. So where my x2 will be 9 minus y1 is 1 over x2 is -1 minus x1 is 3. So here will be 8 minus -4 or equals to -2. So here is the gradient of PQ, which is -2. At forming equation of a straight line. So in this case, in this topic, we have two cases. Next, look at the first cases. Given gradient and a point. Means that in this question, gradient is given and a point is given. So the equation of straight line which has a gradient m and passes through the point x1 and y1 is, so this is the formula that we're going to find, or we're going to use to find the equation of straight line, which is y is equal to mx plus c, or we can use y minus y1 is equal to m times x minus x1. So if you look at example 5, find the equation of the straight line which has a gradient of -2, means that the gradient is given. Our m is equals to -2 and passes through the point -1 and 4. Here is the point. So if the gradient is given and the point is given, we can straightforward find the equation of straight line. So we start with the formula y is equals to mx plus c. If you are using this formula, first we will try to find the value of c. So where am I? Y based on this point. Here is our y. So I will substitute the x and y and m. So here is y, which is 4, is equals to m. M is -2. So first we have to find the value of c. Times x is -1 plus c. So 4 is equals to -2 times -1 is +2 plus c. So c is equals to, when I move 2 to the left hand side, so 4 minus 2 will be 2. Please remember, c is already positive on right hand side. So you just left out in right hand side. You no need to move. Therefore, the equation of straight line will be y is equals to m is -2, -2x plus 2. Or we can use y minus y1 is equals to m x minus x1. In this method, let's say this is method 1, method 2. In this method, we doesn't have to find the value of c. We can straightforward substitute x1 and y1. So y minus y1 is 4 is equals to m is -2, x minus x1. x1 is -1, so minus -1. I have to put in bracket. I change to square bracket. So y minus 4 is equals to -2 x plus 1. Negative will become positive. Y minus 4 is equals to, I try to expand, -2 times x, -2 times 1. So -2x minus 2. So finally, y is equals to -2x minus 2 plus 4. Why? Because I moved -4 to the right hand side. So here will become y is equals to -2x plus 2. You can see that we have both the same answer. So you can use formula in first formula, or you can use the second formula. It's up to you. So you just use either one. So it's either one or method 2. Now we look at the same subtopic, forming equation of straight line. Now we look at case number 2, where 2 point is given. So if 2 point is given, we have 3 steps to follow. First, we need to find the gradient. Step 2, we just select one point, either point 1 or point A or point B. So you can use point A or you can use point B. It's up to you. And then forming the equation of the straight line by using the formula, you can use method 1 or method 2. Now we look at the next example. Find the equation of a straight line which passes through the point. Here is the point and first point and the second point. So let's say if here is point A or here is point P, here is point Q. So first we try to find the gradient. So in step 1, we will find the gradient, where the formula of gradient is y2 minus y1 over x2 minus x1. So let's say I try to label the point x1, y1, x2, y2. So based on the formula, y2 will be 3 minus y1 is 1 over x2 is 7, x1 is 3. So here will become 2 over 4, which is equals to 1 over 2. So now we already have the gradient. Next, we will choose either this point or the second point. So let's say I choose the first point. You can choose the second point. So 3 and 1. So third step, we are using the formula. Let's say y is equals to mx plus c. If we are using this formula, first we have to find the value of c. So where my y based on this point is 1 is equals to m is 1 over 2, x is 3 times 3 plus c. So here is 1 is equals to 3 over 2 plus c. So 1 minus 3 over 2 is equals to c. So our c will be 1 minus 3 over 2. Suppose is negative 1 over 2. Therefore, our equation of the straight line will be y is equals to 1 over 2x plus c. C is negative 1 over 2. Either you are given your answer in this form, or you can simplify by multiply by 2. So here will become 2y is equals to x minus 1. So or you can left your answer in this form, where you multiply by 2, or you can left your answer in this form. Next, determine the gradient from the equation of the straight line. So means that given a straight line or the equation of straight line, we try to determine the gradient or the slope. So any equation of a straight line can be rearranged into the form of y is equals to mx plus c. Means that we have to arrange in this form, and then the gradient of the straight line is the value of m. Means that we have to arrange in this form, y is equals to mx plus c. Means that our left hand side is only y without and the coefficient is 1. So here is the gradient in front, the value in front of x. Let's say we look at example 7. Determine the gradient for each of the following straight line. So for A, y is equals to 3x minus 2. Where in the question A, the equation is already in the form of y is equals to mx plus c. So therefore, our m is equals to 3. So the gradient is equals to 3. If you look at question B, x plus y is equals to 2. So now this form is not in the standard form, which is y is equals to mx plus c. So what I have to do is, I have to move x to the right hand side. So it will become y is equals to negative x plus 2. So again, here is the standard form, y is equals to mx plus c, where our m is not negative but negative 1. So our m is equals to negative 1. Now we look at c. 2x plus 4y is equals to 5. So first I have to rearrange into the form of y is equals to mx plus c. So here will become 4y is equals to negative 2x plus 5. Next, I will divide 4 to the right hand side because on our left hand side is only y. So I have to divide the coefficient of 4 to the right hand side. So it will become y is equals to negative 2x plus 5 over 4. I separate into two parts. So here will become negative 2 over 4x plus 5 over 4. Then I try to simplify. So negative 1 over 2x plus 5 over 4. So here is the standard form. Y is equals to mx plus c. So therefore, our value or our gradient will be m is equals to negative 1 over 2. So through these three examples, you can notice that our equation must be in standard form. Y is equals to mx plus c in order to find the value of m. So means that you have to rearrange your equation where on our left hand side is only y. So if you have 4y, you have to divide by 4. It's only y. So you have to rearrange in order to find the gradient. Next, we look at point of intersection of two lines. So the intersection point of two lines can be determined by solving the equation of the straight line simultaneously. So it means that simultaneous equation. So from equation 1, equation 2, we try to solve it simultaneously. Let's say, given the straight line, 2x plus y is equals to 4, and y minus x minus y is equals to negative 1. Intersect at the point A. Find the coordinate of point A. So if the intersection, we can solve it simultaneously. Let's say 2x plus y is equals to 4, equation 1. X minus y is equals to negative 1, equation 2. So here you can use elimination method or you can use substitute method. It's up to you. Let's say I try to use, of course, elimination method is is faster. But now let's say I use substitute method. Let's say from equation 1, or you can use equation 2. It's up to you. Let's say from equation 1. So I left y as our subject. So y will be equals to 4 minus 2x. Means that I move 2x to the right hand side. It will become 4 minus 2x. Let's say here is equation 3. So next I will substitute equation 3 into equation 2. So equation 2 will become x minus, where my y is 4 minus 2x. So in the bracket, 4 minus 2x is equals to negative 1. So x is equals x minus 4, be careful with the negative here, plus 2x is equals to negative 1. Then I try to solve this part. X plus 2x is 3x. Minus 4 is equals to negative 1. 3x is equals to negative 1 plus 4. So 3x is equals to 3. So x is equals to 1. Now, you already found your value of x. We try to find the value of y. So you can substitute in equation 1, 2, or 3. But I choose equation 3. From equation 3. Y is equals to 4 minus 2, where my x is 1. So y is equals to 4 minus 2, which is y is equals to 2. Therefore, my coordinate of point A will be 1 and 2. So, if you want to find the point of intersection, we will solve the straight line by using simultaneous equation. Next, we look at parallel and perpendicular lines. So for first, we look at the parallel line. So for parallel line, you can see that this is M1 and M2. If two straight line having gradient M1 and M2, so the line 1 is M1, the line 2 is M2, respectively are parallel. If they are parallel, then the gradient M1 is equals to M2. Means that the gradient are the same. We can use the same gradient for both lines because they are parallel. Next, we look at perpendicular lines. So here is the perpendicular line, M1 and M2, line 1 and line 2. So they are 90 degree. In between them are 90 degree. If two straight lines having gradient M1 and M2, respectively, are perpendicular. If they are perpendicular, we need to use this formula. Means that the gradient of M1 multiplied with the gradient of M2 will be equals to -1. So for parallel line, we can directly use the gradient. But for perpendicular line, we have to use the formula in order to find another gradient. So now we look at example 9. Find the equation of the straight line which passes through the point A and parallel. So first you have to know that, you have to notice that parallel means that we have the same gradient. M1 is equals to M2. So we can straightforward use the line, the gradient of this line. So again, find the equation of the straight line which passes through the point A and is parallel to the straight line 6x minus 3y plus 2 is equals to 0. So parallel to this line. So first I have to rearrange the equation in order to find the gradient. So 6x minus 3y plus 2 is equals to 0. The best way is I move negative 3y to the right hand side. Means that from here I should have 6x plus 2 is equals to positive 3y. And then I try to rearrange this one. So it will 3y is equals to 6x plus 2. So y will be 6x plus 2 over 3, or I can try to separate into 2, 6x over 3 plus 2 over 3. Or I can write in the form of y is equals to 2x plus 2 over 3. Which means that our m will be equals to 2. So from here, since they are parallel, so I can use straightforward, I can use the m is equals to 2. And we know that this is passes through, the straight line is passes through the point A. So A will be -2 and 5. Since you already have the gradient and a point, so we can straightforward find the equation of the straight line by using the formula y is equals to mx plus c. So first we try to find the value of c. Substitute y is 5, m is 2, x is -2 plus c. 5 is equals to -4 plus c. So c will be equals to -4 when I move to right hand side, plus 4. So now is 9. So the equation of the straight line will be y is equals to m is 2, 2x plus 9. So means that in this example, if they are parallel, we can straightforward use the gradient because they have the same gradient. Finally, we look at the last example, which is example 10. Find the equation of the straight line which passes through the point Q and is perpendicular. So now we can see that here is perpendicular to the straight line y plus 5x minus 3 is equals to 0. So if perpendicular, we have to do m1 times m2 is equals to negative 1. So let's say, first I try to arrange this equation. Y plus 5x minus 3 is equals to 0. Y will be equals to negative 5x plus 3. Means that our gradient m is equals to negative 5. So in this example, since this is perpendicular, we cannot straightforward use this gradient because they are not parallel. So since they are perpendicular, I have to use this formula. So m1 times m2 is equals to negative 1. You can assume that this is m1 or m2, is up to you. Let's say I assume that this is m1. So negative 5 times m2 will be equals to negative 1. So my m2 will be negative 1 over negative 5. m2 is 1 over 5. So this is the gradient that we're going to use. So now we already have the gradient and then we have the point. So m is equals to is equals to 1 over 5, and then our point Q will be 3 and negative 4. So from here, y is equals to mx plus c, where y is negative 4, m is 1 over 5, and our c is 3. So here is negative 4 is equals to 3 over 5 plus c. Negative 4 minus 3 over 5 is equals to c. So negative 4 minus 3 over 5 will be equals to negative 23 over 5, which is equals to c. Therefore, the equation of the straight line will be y is equals to m. M is 1 over 5. X plus c. Our c is negative 23 over 5. So here is the equation of the straight line. So please remember, if the straight line is perpendicular, we have another step that we need to find by using the formula of m1 and times m2 is equals to negative 1. We're going to use this formula because they are perpendicular. So because they are perpendicular. So we need to use this formula to find the gradient that we need. If they are perpendicular, if they are parallel, again, if they are parallel, we can straightforward use this gradient as our gradient to the new equation, like example 9. If they are perpendicular, we have to add one more step. m1 times m2 is equals to negative 1 in order to find the gradient that we